Hello, I'm Scott Brown, Applications Engineer at Freescale Semiconductor. I'm here to show you the MC9S08QE8 microcontroller, which extends the ultra-low power QE family, offering high integration with an ideal pin and memory combination to help you design energy-efficient and high-performing applications. Let me demonstrate Freescale's ultra-low power technology with our 8-bit 9S08QE8 device. This lab exercises 3 of the QE8's low power modes: low power run, stop 2, and stop 3. During the lab, we will be using Freescale's CodeWarrior IDE version 6.1 in conjunction with the demo 9S08QE8 demo board to load the example software and program the target QE8 processor. We will also be using a high-precision digital multimeter to measure average current consumption of the QE8 and the terminal window application from the Demo QE Toolkit utilities. This utility allows us to display the elapsed time since the program started in hours, minutes, and seconds, as well as display which mode of operation the QE8 device is in. The lab software runs the QE8 device through 4 modes of operation: normal run mode, low power run mode, stop 3 with the external oscillator running, and stop 2 with the external oscillator running. We will be able to cycle through these different modes using the push button switches on the Demo QE board. As we cycle through the different modes, we will continue to monitor changes in average current consumption on our digital multimeter, as well as periodically check that our timekeeper application is still updating. The display will update every 5 seconds with the elapsed time since the last reset. In the LP run mode, the display is not updated, but the total count is continuously updated. Additionally, while running the device in normal run mode, low power run mode, or stop 3, we can demonstrate another low power feature of the QE8 device: clock gating. This feature allows you to turn off clocks to unused peripherals, lowering overall power consumption. Pressing the reset button will toggle the clock gating open and shut. So before getting started, let's get our board set up for the lab. My board is currently in the default out-of-the-box configuration. The first thing we'll need to do is remove jumper 17 and attach our digital multimeter to be able to measure average current consumption. Next, in order to use our external crystal oscillator, we'll need to remove the 2 jumpers at J20 on the board. These jumpers utilize a multiplexed function on the oscillator pins that we will not use during the lab. Finally, an optional step is to remove this jumper at J21 to disconnect the analog potentiometer circuit. This circuit tends to consume a lot of current on its own, and we want to get an accurate idea of just how low power the QE8 device is. Now I'll connect my board to my PC and we can get to our lab exercises. Freescale's CodeWarrior 6.1 includes this low power lab and others for the 9S08QE8 device. So when CodeWarrior starts up, I want to create a new project for this lab. To do this, I will select Load Example Project from the Startup dialog. From Example Projects menu, open the tree to select HCS08 Evaluation Board Examples, Demo 9S08QE8, Demo 9S08QE8 Low Power. Create a new project name, set desired location, and click Create Project. This will open the project for the low power application for the Demo 9S08QE8. This project contains all the software needed for our low power lab, so now we're ready to program the part and go through the exercises. Turn the board power switch to the on position. Compile and program the MC9S08QE8 microcontroller with low power application by clicking on Debug button. This will launch the debugger. From Connection Manager menu, select Demo QE on USB 1 port and click on Connect. Now that we're connected, I want to program the QE8's flash memory. From Erase and Program Flash menu, click on Yes to allow the debugger to mass erase the microcontroller's on-chip flash memory and program it with our low power application code. Now that I have my low power lab software loaded onto my device, and for the application to run correctly, the MCU cannot be in debug mode. Therefore, I'm going to close the debugger window, turn the board power switch off, and then on to power cycle the MCU. Now I will open up the terminal utility. I want to make sure that the port is set to USB COM, and I want to set the baud rate to 9600. At this point, the MCU is now running the low power application in normal run mode. We can note our normal run mode current on the digital multimeter and see that we have an LED blinking to let us know the part is operating. Back in the terminal utility window, click the Open Serial Port button, and we can see the device communicating with our terminal utility. As we observe the output, our count should increase by 5 every 5 seconds. Now let's start trying out the other modes of operation. Click the button labeled PTA3 on the board to enter LP run mode. After displaying that we are entering low power run mode, the terminal updates will cease, but the PTCO LED will continue to blink. We'll go ahead and wait 5 or more seconds before jumping back into normal run mode to demonstrate that despite not updating the display, our QE8 is still keeping count. While we wait, let's take a look at our average current consumption in low power run mode. You'll notice that it is significantly less. We also see that a second LED is lit, letting us know that we are in low power run mode. Click the button labeled PTA2 on the board to re-enter normal run mode. Our current returns to the previous level. Our LEDs also return to their normal run state, and the terminal updates resume with accurate total count. At this time, I'll click the button labeled PTD2 on the board to enter Stop 3 mode. The MCU will wake from Stop 3 mode every 5 seconds and update the total count. The terminal tells us we have entered Stop 3, and a different LED lights to signify the same, and we can note a much lower average current. Keep in mind, the actual stop current is much lower than what is displayed. This average current accounts for the QE8 waking up to update the terminal count. Now I will put the device in its lowest power state. When I click the button labeled PTD3 on the board, the device will enter Stop 2 mode. The MCU will wake from Stop 2 mode every 5 seconds and update the total count. Again, let's note the reduction in average current consumption. To exit from Stop 2 mode, I will hold the PTA2 button down until the terminal window shows a return to normal run mode. This can take up to 5 seconds. Now that we've seen the average current consumption in the different low power modes, let us see how the clock gating feature helps us to achieve even lower current consumption. We will see the biggest difference in normal run mode. Clicking the button labeled Reset will toggle the clock gates open and shut. Here, we will see the difference in normal run mode with clock gates open and now shut, and now open again, and now shut again. Clock gating offers the biggest power savings in normal run mode, and while there are some savings in other modes, it is relatively small. So, whether it is ultra low power or high performance, the QE8 with its rich peripheral set makes the development process flexible by allowing you to choose what you need from a wide range of features. To explore the flexibility of the QE8 for yourself, order a Demo 9S08 QE8 demonstration kit that includes the software for this low power lab as well as other labs, highlighting the additional features on the QE8.